When you look up at the night sky, what are you really seeing? It's not just stars, right? You're looking at thousands, maybe millions of other solar systems, and each one has its own family of planets. So today, we're going to blast right past our familiar neighbors, Mars, Jupiter, even Pluto, and dive into the really weird stuff, the downright impossible worlds orbiting those distant suns. And we're going to kick things off with a planet that's making scientists tear up the old rulebook.
Yeah, this isn't just any old discovery. We're talking about a planet that has astronomers just scratching their heads, completely stumped. It's a world so bizarre, it's challenging everything we thought we knew about how planets are even made. It's forcing us to ask, what even is a planet? So, let me introduce you. Its name is PSR J2322650b. And yeah, I know, it's a mouthful. But this discovery, brought to us by the amazing James Webb Space Telescope, is an absolute cosmic enigma. It's a world that, by every law of physics we know, just shouldn't exist. Okay, so get ready for this, because the list of weirdness is long. First off, it's as big as Jupiter. But the star it orbits? It's a super dense neutron star, only about the size of a city. The gravity is so insane, it's literally stretching the planet into the shape of a lemon. The atmosphere? Choked with carbon, filled with these dark, sooty clouds. And deep down inside, well, the pressure might be so intense that it's creating a core of diamonds. And the real kicker? Scientists have absolutely no idea how it got there.
Think about this. A year, one full trip around its star, takes less than 8 hours. 8 hours? That is just mind-bogglingly fast. I mean, to put that in perspective for you, Mercury is our fastest planet, and its year is 88 days. This thing is practically scraping the surface of its star. It's locked in this incredibly tight, deadly dance.
And look, it wasn't just us regular folks who were blown away. The actual scientists who found it, they were completely floored. I mean, Peter Gao from the Carnegie Earth and Planets Laboratory put it perfectly. He said, "I remember after we got the data down, our collective reaction was, what the heck is this?" And, when you make seasoned astrophysicists say that, you know you've stumbled onto something really, really special.
Which brings us to the million-dollar question, right? How can a planet like this even exist? Well, to even start to wrap our heads around that, we kind of need to take a step back and figure out what a normal planet even looks like out there.
So, let's do a quick reset. We're going to take a quick tour of the exoplanet zoo, so to speak, because, before you can truly appreciate the weird, you got to know what's considered normal. All right, first things first, the absolute basics. What's an exoplanet? Simple. It's any planet that orbits a star that isn't our sun. That's it. Sounds pretty straightforward, right? But oh man, the sheer variety packed into that simple definition, that's where it gets really, really cool. This idea of other worlds, it's not new. People have been thinking about it for centuries. Back in the 16th century, a philosopher named Giordano Bruno even got in major trouble for suggesting it. But it took all the way until 1992 to actually find one. And funny enough, the first one we found was orbiting a dead star, a pulsar. A few years later, in '95, we found the first one around a sun-like star. And now, today, we've found over 3,000 confirmed exoplanets. And that number is just climbing all the time. So what are we finding out there? Well, it's a whole cosmic menagerie. You've got your familiar types, like gas giants and rocky planets. But then you get into things like super-Earths, which are basically rocky worlds way bigger than ours, and these things called hot Jupiters. These are huge gas giants that are orbiting their stars incredibly close. So these are kind of the standard types you find, but then there are the planets that just don't play by the rules. Okay, now for something completely different. Imagine a planet with no sun. I mean, think about that. No sunrise, no sunset. Just a world drifting all by itself through the endless dark night of interstellar space. Sounds like something out of sci-fi, right? But it's real. They're called rogue planets.
And the official definition is, well, it's about as lonely as it sounds. A rogue planet is basically a cosmic orphan. It's a planet-sized object that's not tied to any star. It's just wandering the galaxy all on its own. The ultimate drifter.
Now, here is where it gets absolutely mind-blowing. Scientists estimate that in our Milky Way galaxy alone, there could be billions, maybe even trillions of these sunless worlds. Think about that. For every single star you see in the night sky, there could be dozens, hundreds of these dark, wandering planets that we can't see. It's like this massive, unseen population of cosmic ghosts. So how does a planet go rogue?
Well, there are two main ideas. The first is that it kind of tries to be a star. A gas cloud starts collapsing in on itself, but it just doesn't have enough mass to light up. It's basically a failed star. The other path is a lot more dramatic. Imagine you're a planet born in a nice, normal solar system. But then, you get into a gravitational fight with one of your bigger sibling planets, and bam, you get violently kicked out, flung into the cold, empty darkness of space.
But here's the thing. You don't actually have to look trillions of miles away to find these cosmic puzzles. We've got some seriously weird planets right here in our own backyard.
Let's talk about Uranus and Neptune. For a long time, we kind of called them the ice giant twins. I mean, they're both big, they're blue, they're icy. But the more we learn, the more we realize that these two siblings are, well, they couldn't be more different. And it's a real mystery.
Okay, just check this out. Uranus is completely knocked over on its side. It's tilted at 98 degrees, so it's basically rolling through space. It's also the coldest planet in the solar system. For some reason, it gives off almost no heat from its core. Then you look at Neptune. It has a pretty normal tilt, about 28 degrees, but it's like a furnace inside. It radiates more than twice the heat it gets from the sun. What is going on with these two?
Well, the leading theory is pretty wild. Giant impacts. The idea is that way back in the early days of the solar system, both of these planets got absolutely smashed by other huge world-sized objects. Maybe Uranus got hit with a kind of glancing blow that just tipped it over on its side. And maybe Neptune got hit head-on, a collision that just churned up its insides and is still making all that heat. It's a good reminder that planet formation isn't some gentle process. It's a chaotic, cosmic demolition derby.
And here's why solving this mystery is so important. As we keep finding more and more exoplanets, it turns out that planets like Uranus and Neptune might actually be the most common type in the whole galaxy. So if we can figure out our own weird ice giants, that could be the key to understanding thousands, maybe millions of other solar systems. And that really is what this is all about. A planet that shouldn't exist. Trillions of lonely, wandering worlds. Mismatched twins right here at home. You see, for scientists, these aren't problems to be frustrated by. They're puzzles. As Roger Romani at Stanford said, it's great to have a puzzle to go after. Every single one is an invitation to learn something new about our incredible universe.
So, from planets shaped like lemons with diamond cores to entire worlds knocked over on their sides, the universe has proven again and again that it's way stranger and way more creative than we ever could have imagined. And that just leaves us with one final exciting question. What other impossible worlds are out there, just waiting to be discovered?